All right, welcome. You made it to the very first lesson. Now, before we touch Unity, before we even open the app, I want to ask you something. Think about any game you've played. Doesn't matter what it is, a character runs, something explodes, a door swings open when you walk up to it. All of that is happening live, right? Nothing is frozen. The world just keeps going. Have you ever stopped and wondered, okay, but what is actually making that happen? That's exactly what we're unpacking in this lesson. So here's the thing, every game, every simulation, every interactive experience at its core is running a loop. And I mean a fast loop. We're talking 30, 60, sometimes 120 times every single second. And each cycle of that loop, the engine does three things. It checks what's changed. Did the player press a button? Did something collide? Then it updates the whole world based on that. Then it draws everything on screen. Input, update, render, repeat. That's it. That's the heartbeat of every real time application ever made. And here's why that matters. You don't have to build that loop. Unity runs it for you. Your job is just to describe what's in the world and how things behave. Unity takes care of the rest. That's genuinely a big deal, especially when you're starting out. Now, I want to address something because it trips people all the time. Unity is not a programming language. I know that might sound obvious, but you'd be surprised how many people come to think I need to learn Unity and I need to learn to code are the same thing. They're not. C Sharp is the programming language you'll eventually write inside Unity. But Unity itself is the environment, the engine. Think of it like this. Microsoft Word isn't the English language. English is what you write in Word. Same idea here. Next, Unity is also not a 3D modeling tool. If you've heard of Blender, awesome software, by the way. That's where you build and sculpt 3D objects. Unity is where you take those objects and bring them to life inside a world. So Blender makes the stuff, Unity makes the stuff do things, very different jobs. And Unity is not a finished product either. It doesn't make games on its own. It gives you the tools to make games. That distinction matters because it sets the right expectation from day one. Now, here's something that surprises a lot of people. Yes, Unity is famous for games, and some of the most beloved indie games ever made were built in Unity, but the engine is being used way beyond that. Architects are using it to let clients walk through buildings before a single brick is laid. Car companies are using it for interactive design, reviews, and showroom experiences. Medical and military organizations are running training simulations in it. Theme parks are using it for ride experiences. The common thread, all of this need a real-time loop. They all need a world that responds to input, updates, and renders live. So if you're coming to this course thinking I don't want to make games, that's totally fine. The foundations are the same no matter what you're building. Now, last thing before we wrap up, and I think this is usually or actually the most important thing I'll say in this entire module. Learning a programming language is mostly about learning rules, syntax, grammar. You memorize patterns. Learning a game engine is different. You're learning a system, a way of thinking about the world. Unity has its own mental model, objects, components, scenes, and once that mental model clicks, everything else, the code, the AI tools, all of it starts falling into place and naturally. That's why in this course, we're not rushing straight into writing scripts or generating assets. So we're building the mental model first. That's the foundation everything else sits on. So there you have it. A real-time engine runs a continuous loop, input, update, render, and Unity manages that entire loop for you. It's not a programming language, it's not a modeling tool, and it's definitely not just for games. So in the next lesson, we're going to zoom out a bit and look at where Unity sits in the broader industry and how it stacks up against the other engines you might have heard about. So all of that and more, I'll see you in the next lesson. So, in the last lesson, we talked about what a real time engine actually does under the hood. And now, let's just zoom way out. Because here's a question worth asking before you invest serious time in any tool. Who's actually using this thing and for what? Unity is not a niche product. It's not an indie secret weapon. It's one of the most widely deployed pieces of software in the real time space. And I think understanding that will give you a genuine sense of what you're getting into. So let's start with games because that's probably why most of you all are here. Unity has a massive footprint in mobile gaming. Think about how many games if you've scrolled past on the App Store. A huge percentage of them are built in Unity. It's the go-to for mobile because it's lightweight, it compiles fast, and it targets iOS and Android from the same code base. But it's not just mobile. PC and console games, indie titles, some of the most beloved of the last decade came out of Unity. Game like Hollow Knight, Cuphead, Among Us, these aren't small accidents. These are intentional choices by studios who wanted control, flexibility, and massive community behind them. Even in the AAA territory, the big budget, hundreds of people productions, Unity has a presence. It's not the dominant engine there, but it's there. Now, here's where it gets interesting. Even if you're not a game developer, remember, last lesson when I mentioned architects using Unity, let's go a little deeper on that. Before building is constructed, before a single piece of steel goes up, clients can walk through the building in real time. Change the lighting, open doors, look out the windows. That's a Unity. Automotive companies use it for interactive showroom experience and design reviews. You can spin a virtual car, swap the paint color, look under the hood, all in real time. And military and medical organizations run training simulations, surgical procedures, emergency scenarios, combat environments. Real stakes, but in a safe context. And the common thread in all of this, they all need the same loop we talked about. Live input, live update, live render. That's all Unity is at its core. Okay, so you've probably heard of at least one other engine, Unreal Engine, maybe Godot too. Let's be honest about how they're different. Unreal Engine, made by Epic Games, is the powerhouse for high-fidelity visuals. When you see a game that looks almost photorealistic, when lighting looks indistinguishable from real life, there's a solid chance it's Unreal. It's the default choice for a lot of AAA studios, and it uses C++ as its core language. Unity's philosophy is different. It prioritizes flexibility. It's stronger on mobile, it's more approachable, and it uses C#, which is a friendlier language to learn. Neither is better, they're just different tools built with different priorities. Then there's Godot. Godot is fully open source, free forever, no strings attached. It's a great engine genuinely, but its ecosystem is smaller, its asset store is thinner, and its platform support doesn't match a Unity's. Which brings me up to maybe the single biggest practical advantage Unity has. Write your project once, ship it to 25 plus platform, iOS, Android, Windows, Mac, PlayStation, Xbox, Nintendo Switch, VR headset, web browsers, one project. That's not a major convenience, that's a business decision. So that's the landscape. Unity sits at a unique intersection. Powerful enough for professional production, flexible enough for every platform, and approachable enough that you don't need graphics engineering PhD to get started. It's not the only engine, and it's not perfect for everything, but understanding why it exists, where it does in the industry makes you a smarter developer from day one.